Hello friends, welcome back to my channel Power Plant in a Nutshell. This is the second video in the compressed air system series. In my earlier video, I have touched upon the topic of compressors, in which I have covered uh, general PNID of a compressor, means what is aftercooler, what is intercooler, how we do about the work in a compressor, then why we require compressed air system. In this second video, I would be covering upon the types of compressors. The types of compressors basically include reciprocating compressors, uh, centrifugal compressors, and many other things. So, without wasting much time, let's start with the video. Before I move on to explain the different types of compressors, I need you to understand the in principle difference between the two major categories of compressors, which are positive displacement compressors and the dynamic compressors. And for that thing to understand, you must be clear with the concept of compressor operational theory. There are basically two ways of compressing the any gas particle. The first way is the volume of a gas, and since we all know in case of gas we have PV is equal to C constant. So if I reduce the volume of a gas, then I can convert this into a pressure. So the first way of compressing a gas is by decreasing the volume of a gas, and thus helping me to convert this decrease of volume into increase of pressure. The other way of doing this is by imparting the kinetic energy to a gaseous molecule or gaseous particles. Since I think most of you must be clear with the concept of the Bernoulli's equation. In the Bernoulli's equation, it has been clear to us that if the total energy imparted is constant, then at place 1 and place 2, then I can easily say that the sum of pressure energy plus potential energy plus kinetic energy at point 1 should be equal to the sum of pressure energy, kinetic energy and the potential energy. So by imparting the kinetic energy, I can easily convert it into the pressure energy at the place of my requirement. So the compressor operation theory is basically about the two different ways of compressing a gas particle. One by reducing the volume and increasing the pressure, and the another by imparting the kinetic energy and converting into the potential energy at the source of our requirement. So continuing further, so as I explained in my previous slide, there are basically two types of compressors. One is the dynamic compressors and another is the positive displacement compressors. So the positive displacement compressors can be further subtype into rotary compressors, which include screw type compressors, rotary vane compressors, and the reciprocating compressors, which are single acting, double acting, multiple acting type compressors. And if I break down the dynamic compressors, then I have either the radial compressors or the axial compressors. So let's move on to the discussing the individual characteristic of each compressor. The basic characterization of positive displacement compressor is that these compressors find normally their applications at places where there is a requirement of a high pressure and low to medium flow. And the basic methodology of working of these compressors is based on decreasing the volume of a gas and converting the same into the pressure, as I have discussed earlier. Now I will further discuss the two basic types of positive displacement compressors. The first one is the reciprocating compressors. These are the most widely used compressors in the market, and the most important point with them is that their flow output remains constant across the range of discharge pressures, and the total flow or compressor output is basically dependent upon the speed of the piston or the speed of the pulsating rod. So normally the reciprocating compressors are characterized as a more or less constant flow compressors in which we get the high pressure but the flow rate is less, and at the same time the output is actually a pulsating in nature. There are further different types of reciprocating compressors which have been developed to reduce this pulsation, which are single acting reciprocating compressors, dual acting reciprocating compressors, triple acting reciprocating compressors, and the four loop multiple reciprocating compressors. So these type of compressors actually reduce the pulsating nature and thus smoothen the flow of the compressor's output or the flow of the air from the compressor output in a smooth way. Nowadays, the rotary compressors are finding their use in the compressor industry, and the basic reason behind this increase of or the increase in demand of the rotary compressor is that nowadays the reciprocating rotary compressors which are coming into the market are oil free. So therefore the quality of the air which is coming from these compressors is of very good. Now the basic fundamental difference of rotary compressor from the reciprocating compressor is that though the reciprocating compressors, though similar to reciprocating compressor, the rotary compressors also reduces the volume of a gaseous particle or molecule, but at the same time the rotary compressors also impart the sum of the kinetic energy because of the motion of the vanes or the screws or anything etc which is there, or the gear I would say. So the rotary compressors is actually more or less a mixture of reciprocating compressors as well as the dynamic compressors. One more example, or I would say the pros of a rotary compressor, is that the rotary compressors doesn't have an output which is pulsating in nature. It has a smoother output, and the flow of the air from the compressor is generally a continuous in nature. So next come to the another type of compressors, that is dynamic compressors. The dynamic compressors, as discussed in the my third slide, in which I have talked about the compressor operation theory. So the dynamic compressor worked upon the principle of imparting the kinetic energy and converting this kinetic energy into pressure energy at the place of their requirement. These compressors are normally characterized by a very high flow and a medium to low pressures. Therefore, if the your requirement of a flow is high, then one should definitely go for either rotary compressors or the dynamic compressors. And if the volume of a flow is less, or the basic principle is to have a very high pressure requirement, then at that place of point we must go for the reciprocating compressors. So now this dynamic compressors can be further subdivided into radial compressors and axial compressors. The radial compressors are those compressors whose uh, discharge is 90 degree to the suction, and the axial compressors as shown in this picture is those compressors in which the discharge is in the similar line or is in the same line as the suction. So where do we use the radial compressors and where do we use the axial compressors? The radial compressors are again characterized that in case if you have to go for the centrifugal compressors only or the dynamic compressors only, then and at the same time you require a higher pressure, then one should go for the radial compressors. And if the basic requirement is more towards the efficiency and the flow, then one should go for the axial compressors. So axial compressors are those in which the efficiency is the main motive or the flow is would be the main motive, and the radial compressors are those in which the main motive would be to gain a higher and higher pressure. So in this slide I have discussed upon the basic selection criteria of a compressor. So the first and the foremost criteria is the capacity. The second is the discharge pressure of a compressor. The third is the compressor operating level, then the elevation, then the inlet temperature, the humidity, the availability of the cooling water, what are the atmospheric conditions, whether they are dry, whether they are corrosive, or many other things. So these all factors actually play a major role in selecting the type of compressor. Further, as seen from this table, that the basic thing which I have explained you earlier also, that the centrifugal compressors are normally suited where the flow requirement is high, that is the centrifugal compressors range from 600 CFM to 30,000 CFM, and the reciprocating or the screw compressors, or I would say the rotary compressors, are characterized by the high pressure requirement. So that's all in the types of compressor. I hope you had liked the video and you have understood the topic of different types of compressors, and you can use this knowledge in your day-to-day life. So if you like my channel, please click a like button, subscribe to my channel, and in next few days I will be posting my third video on this topic, that is the tripod types of dryer, and finally I will cover upon the energy efficiency aspects of a compressor. So till then, good night, take care.